This is the screencast for example 8, section 1.1. We're going to apply the problem solving process to a lot of these methods that we've been talking about: algebraic, numeric, graphical. The engineers at an auto manufacturer pay students 8 cents per mile plus $25 per day to road test their new vehicles. Is that a job you want? I don't know. Is that true? I don't know. How much did the auto manufacturer pay Sally to drive 440 miles in one day? And then part B asks, so John earned $93 test driving a new car in one day. How far did he drive? So the first thing we need to do is come up with a model to represent what's happening in this situation. So engineer pay students 8 cents per mile plus $25 per day. Now in reading ahead, see, it sounds like days is a variable depending on how many days they drive. But in reading ahead, Sally drives one day and John drives one day. So days is not actually a variable. The two variables we have are P, which is going to represent the total paid. And now you can call that Y, you can call that Q, it doesn't matter. And then M equals the number of miles driven. Our model is going to be P equals, let's see, we've got $25 per day plus 8 cents per mile. Now typically we're used to seeing this in slope-intercept form, so if you want to rewrite that as 0.08 m plus 25, that's fine too. It's asking us to solve algebraically, so there's the same model is going to be used for both parts A and part B. So we're going to take part A and we're going to solve that algebraically. How much did the auto manufacturer pay Sally? So we're going to try to be finding P when she drove 440 miles in one day. So I'm going to say P equals 0.08 times 440 plus her $25, which means she got paid a total of $60.20. Now for part B, John earned $93, so that's his p-value, and that equals, let's see, 0.08 m plus 25. So we need to solve for m for him. So we're going to subtract 25 from both sides. 68 equals 0.08 m. Divide both sides by 0.08. And we get that John drove 850 miles. It's pretty far. Now we need to support that graphically. So what I did in my calculator is I already put in 0.08x plus 25, and we're going to go zoom 6. I have no idea what kind of window. No, that's not good. And I don't even see any graph whatsoever. So a trick that I have is if I hit the trace key, I can see that my y value goes up to 25 when x is 0, which makes sense because that's my y-intercept. So now just for somewhere to start off, I'm going to change my y maximum not to 25, but to something bigger than that. I want to see more of this graph. So I'm going to go with 50. Maybe that's not enough. Maybe I need 100. We'll see. That looks okay. Now we're talking 850 miles or 440 miles. So miles is the x-axis here. So I'm going to change my x maximum not to 10 miles, but to, let's go with 1,000 miles. So I can easily fit 850 miles in my graph somewhere. See, now that tells me that I haven't gone high enough because, let's see, he earned $93, so I can take my Y max and go up to maybe $125 to see all of the values I need clearly. There we go. Now I have a nice line that goes all the way out to 1,000 miles. I can find out what happened over 1,000 miles and up to, what did I say, $125. So now, hit the trace key, and we can quick check both of these. I'm going to input 440. So this is telling my calculator, find the value for y when x equals 440, hit enter. And I got 60.2 2, which is exactly how much money, who was that? Sally made. John earned $93. Unfortunately, we don't have a way to enter in a Y value, but I think the X value that goes with him is 850 miles. So if I plug in 850 miles for X, I get $93 for Y, which does verify graphically that we are correct. Now the interpretation for this model is simply that Sally earned $60.20 for driving the 440 miles in one day, and John drove 850 miles in one day, earning him the $93. Basically a summary of the problem. The now try problem that goes with example 8 is number 47. Swan Auto Rental charges $32 per day plus 18 cents per mile for an automobile rental. So part A, Elaine rented a car for one day and she drove 83 miles. How much did she pay? And part B asks, Ramon paid $69.80 to rent a car for one day. How far did he drive? So again, it sounds like this is going to depend on how many days these people drive, but they're all driving for one day. So that's actually not a variable in this equation. That is a constant. It's one day, so we don't have to worry about how many days. So I've done the work ahead of time because this is a basic linear problem that you've worked with in Algebra 1 and Algebra 2. So now to solve graphically, I have to look at values that I've dealt with in this problem so far because Zoom 6 is definitely not showing me any graph. So let's see, I've got 210 miles, 83 miles, so maybe I want to go up to 300 miles, and M is my X value. So I'm going to change my X max to 300 miles. 250 might be fine, but I'm going to go with 300. Now my Y values, the Y values are C. So the Y min and Y max are, we're talking about the cost of this rental. I've got $46.94 or $70. I'm going to go up to $100 for my Y max. And then hit graph. Now I'm going to double check my work. Trace. First let's check Elaine. She went 83 miles, so I'm going to input that for my X value. Sure enough, I got $46.94, which is exactly what I thought it was going to be. Good for me. And then I need to check Ramon. Now I can't plug in $69.80 because I can't plug in Y values to my calculator, but I think the X value that goes with that is 210. So when I plug that in, I sure enough get $69.80. So my interpretation on this model is that Elaine paid $46.94 to go 83 miles in her rental car, and Ramon paid $69.80 to go 210 miles in his rental car.